everyone, and welcome to the new stack in Ops for AI, going from prototype to production. My name is Sherwin, and I lead the engineering team for the OpenAI developer platform, the team that builds and maintains the APIs that over 2 million developers, including hopefully many of you, have used to build products on top of our models.
And I'm Shyamal. I'm part of the Applied team, where I work with hundreds of startups and enterprises to help them build great products and experiences on our platform.
And today, we're really excited to talk to you all about the process of taking your applications and bringing them from the prototype stage into production. But first, I wanted to put things into perspective for a little bit. While it might seem like it's been a very long time since ChatGPT has entered our lives and transformed the world, it actually hasn't even been a full calendar year since it was launched. ChatGPT was actually launched in late November 2022, and it hasn't even been a full 12 months yet. Similarly, GPT-4 was only launched in March 2023, and it hasn't even been 8 months since people have experienced our flagship model and try to use it into their products. In this time, GPT has gone from being a toy for us to play around with and share on social media into a tool for us to use in our day-to-day lives and our workplaces, into now a capability that enterprises, startups, and developers everywhere are trying to bake into their own products. And oftentimes, the first step is to build a prototype. And as many of you probably know, it's quite simple and easy to stand up a really cool prototype using one of our models. It's really cool to come up with a demo and show it to all of our friends. However, oftentimes there's a really big gap in going from there into production. And oftentimes it's hard to get things into production. And a large part of this is due to the non-deterministic nature of these models. Scaling non-deterministic apps from prototype into production can oftentimes feel quite difficult without a guiding framework. Oftentimes, you might feel something like this, where you have a lot of tools out there for you to use. The field is moving very quickly. There's a lot of different possibilities, but you don't really know where to go and what to start with. And so for this talk, we wanted to give you all a framework to use to help guide you moving your app from prototype into production. And this framework we wanted to provide to you is in the form of a stack diagram that is influenced by a lot of the challenges that our customers have brought to us in scaling their apps. We'll be talking about how to build a delightful user experience on top of these LLMs. We'll be talking about handling model inconsistency via grounding the model with knowledge store and tools. We'll be talking about how to iterate on your applications in confidence using evaluations. And finally, we'll be talking about how to manage scale for your applications and thinking about cost and latency using orchestration. For each one of these, we'll be talking about a couple strategies that hopefully you all can bring back and use in your own different products. So oftentimes, first, we just have a simple prototype. And at this point, there isn't a whole stack like what I just showed. There's usually just a very simple setup here where you have your application and it's talking directly with their API. And while this works great initially, very quickly you'll realize that it's not enough.
So let's talk about the first layer of this framework. Technology is as useful as the user experience surrounding it. And while the goal is to build a trustworthy, defensive, and delightful user experience, AI-assisted co-pilots and assistants present a different set of human-computer interaction and UX challenges. And the unique considerations of scaling applications built with our models makes it even more important to drive better and safe outcomes for users. So we're going to talk about two strategies here to navigate some of the challenges that come with building apps on top of our models, which are inherently probabilistic in nature. Controlling for uncertainty and building guardrails for durability and safety. Controlling for uncertainty refers to proactively optimizing the user experience by managing how the model interacts and responds to the users. Until now, a lot of products have been deterministic, where interactions can happen in repeatable and precise ways. But this has been challenging with the shift towards building language user interfaces. And it has become important to design for human centricity by having the AI enhance and augment human capabilities rather than replacing human judgment. When designing ChatGPT, for example, we baked in a few UX elements to help guide the users and control for this inherent uncertainty that comes with building apps powered by models. The first one, depending on the use case, the first strategy here is to keep human in the loop and understand that the first artifact created with generative AI might not be the final artifact that the user wants. And so giving the users an opportunity to iterate and improve the quality over time is important for navigating uncertainty and building a robust UX. The feedback controls, on the other hand, also provide affordances for fixing mistakes and are useful signals to build a solid data flywheel. Another important aspect of building transparent UX is to communicate the system's capabilities and limitations to the users, so the user can understand what the AI can or cannot do. You can take this further by explaining to the user how the AI can make mistakes. In ChatGPT's case, this takes the form of an AI notice at the bottom. This sets the right expectations with the user. Finally, a well-designed user interface can guide user interaction with the AI to get the most helpful and safer responses and the best out of the interaction. This can take the form of suggestive prompts in ChatGPT, which not only help onboard the users to this experience, but also provides the user an opportunity to ask better questions, suggest alternative ways of solving a problem, inspire, and probe deeper. All three of these strategies really put the users in the center and at the control of the experience by designing a UX that brings the best out of working with AI products and creating a collaborative and human-centric experience. To establish a foundation of trust, and for you to build more confidence in deploying your GPT-powered applications, it's not only important to build a human-centric UX, but also to build guardrails for both stirrability and safety. You can think of guardrails as essentially constraints or preventative controls that sit between the user experience and the model. They aim to prevent harmful and unwanted content getting to your applications, to your users, and also adding stirrability to the models in production. Some of the best interaction paradigms that we've seen developers build have built safety and security at the core of the experience. Some of our best models are the ones that are most aligned with human values. And we believe some of the most useful and capable UX bring the best out of safety and stirrability for better, safer outcomes. To demonstrate an example of this, let's start with a simple prompt in DALL-E, very timely for Christmas, to create an abstract oil painting of a Christmas tree. DALL-E uses the model to enhance the prompt by adding more details and specificity around the hues, the shape of the tree, the colors and brush strokes, and so on. Now, I'm not an artist, so I wouldn't have done a better job at this, but in this case, I'm using DALL-E as a partner to bring my ideas to imagination. Now, you might be wondering, how is this a safety guardrail? Well, the same prompt enrichment used to create better artifacts also functions as a safety guardrail. If the model, in this case, detects a problematic prompt that violates the privacy or rights of individuals, it will suggest a different prompt rather than refusing it outright. In this case, instead of generating an image of a real person, it captures the essence and then creates an image of a fictional person. So we shared one example of a guardrail that can help with both stirrability and safety. But guardrails can take many other forms. Some examples of this are compliance guardrails, security guardrails, and guardrails to ensure that the model outputs are syntactically and semantically correct. And guardrails become essentially important when you're building interfaces for highly regulated industries, where there is low tolerance for errors and hallucination, and where you have to prioritize security and compliance. So we built a great user experience with both stirrability and safety, but our journey doesn't end there.
So at this point, you've built a delightful user experience for all of your users that can manage around some of the uncertainty of these models. And while this works really great as a prototype, when the types of queries that you'll be getting from your users are pretty constrained, as you scale this into production, you'll very quickly start running into consistency issues. Because as you scale out your application, the types of queries and inputs that you'll get will start varying quite a lot. So with this, we want to talk about model consistency, which introduces a second part of our stack involving grounding the model with the knowledge store and tools. Two strategies that we've seen our customers adopt pretty well here to manage around the inherent inconsistency of these models include, one, constraining the model behavior at the model level itself, and then two, grounding the model with some real-world knowledge using something like a knowledge store or your own tools. The first one of these is constraining the model behavior itself. And this is an issue because oftentimes it's difficult to manage around the inherent probabilistic nature of LLMs, and especially as a customer of our API where you don't have really low-level access to the model, it's really difficult to kind of manage around some of this inconsistency. And so today, we actually introduced 2 new model-level features to help you constrain model behavior, and wanted to talk to you about this today. The first one of these is JSON mode, which, if toggled on, will constrain the output of the model to be within the JSON grammar. And the second one is reproducible outputs using a new parameter named seed that we're introducing into chat completions. The first one of these, JSON mode, has been a really commonly asked feature from a lot of people, and it allows you to force the model to output within the JSON grammar. Oftentimes, this is really important to developers because you're taking the output from an LLM and feeding it into a downstream software system. And a lot of times, in order to do that, you'll need a common data format, and JSON is one of the most popular of these. And while this is great, one big downfall of inconsistency here is when the model outputs invalid JSON, it'll actually break your system and throw an exception, which is not a great experience for your customers. JSON mode that we introduced today should significantly reduce the likelihood of this. The way it works is something like this, where in chat completions, we've added a new argument known as JSON schema. And if you pass in type object into that parameter and you pass it into our API, the output that you'll be getting from our assistant or from the API will be constrained to within the JSON grammar. So the content field there will be constrained to the JSON grammar. While this doesn't remove 100% of all JSON errors, in our evals that we've seen internally, it does significantly reduce the error rate for JSON being output by this model. The second thing is getting significantly more reproducible outputs via a seed parameter in chat completions. And so a lot of our models are non-deterministic, but if you look under the hood, there are actually 3 main contributors to a lot of the inconsistent behavior happening behind the scenes. One of these is how the model samples its tokens based off of the probabilities that it gets. So that's controlled by the temperature and the top P parameters that we already have. The second one is the seed parameter, which is the random number that the model uses to start its calculations and base it off of. And the third one is this thing called system fingerprint, which describes the state of our engines that are running in the back end and the code that we have deployed on those. As those change, there will be some inherent non-determinism that happens. As of today, we only give people access to temperature and top P. And starting today, we'll actually be giving developers access to the seed parameter as an input and giving developers visibility into system fingerprint in the responses of the chat completions model. And so in practice, it looks something like this, where in chat completions, there will now be a seed parameter that you can pass in, which is an integer. If you pass in a seed like 1, 2, 3, 4, 5, and you're controlling the temperature, setting it to something like 0, your output will be significantly more consistent over time. And so if you send this particular request over to us like 5 times, the output that you'd be getting under choices will be significantly more consistent. Additionally, we're giving you access to the system fingerprint parameter, which on every response from the model will tell you a fingerprint about our engine system under the hood. And so if you're getting the exact same system fingerprint back from all your responses and you passed in the same seed and temperature 0, you're almost certainly going to get the same response. Cool. So those are model level behaviors that you can actually very quickly pick up and just try with even today. A more involved technique is called grounding the model, which helps reduce the inconsistency of the model behavior by giving it additional facts to base its answer off of. The root of this is that when it's on its own, a model can often hallucinate information, as you all are aware of. A lot of this is due to the fact that we're kind of forcing the model to speak, and if it doesn't really know anything, it'll have to try and say something, and a lot of the times it'll make something up. The idea behind this is to ground the model and give it a bunch of facts so that it doesn't have nothing to go off of. And so concretely, what we'd be doing here is in the input context, explicitly giving the model some grounded facts to reduce the likelihood of hallucinations from the model. And this is actually quite a broad sentiment. The way this might look in a system diagram is like this, where a query will come in from your user, it hits our servers, and instead of first passing it over to our API, we're first going to do a round trip to some type of grounded fact source. Let's say we pass the query in there. Then, in our grounded fact source, it'll ideally return some type of grounded fact for us. And then we will then take the grounded fact and the query itself and pass it over to our API. Then, ideally, the API takes that information and synthesizes some type of response using the grounded fact here. And so to make this a little bit more concrete, one way that this might be implemented is using RAG, or vector databases, which is a very common and popular technique today. In this example, let's say I'm building a customer service bot, and a user asks, how do I delete my account? And this might be specific to my own application or my own product, so the API by itself wouldn't really know this. Let's say I have a retrieval service like a vector database that I've used to index a bunch of my internal documents and a bunch of my FAQs about support, and it knows about how to delete documents. What I would do here first is do a query to the retrieval service with how do I delete my account. Let's say it finds a relevant snippet for me here that says in the account deletion FAQ, you go to settings, you scroll down, click here, whatever. We would then pass that along with the original query to our API, and then the API would use that fact to ground some response back to the user. So in this case, it would say, to delete your account, go to settings, scroll down, click here. And so this is one implementation, but actually this can be quite broad. And with OpenAI function calling in the API, you can actually use your own services, and we've seen this used to great effect by our customers. And so in this case, instead of having a vector database, we might use our own API or our own microservice here. And in this case, let's say a customer is asking for what the current mortgage rates are, which, of course, even our LLMs don't know immediately because this changes all the time. But let's say we have a microservice that's doing some daily sync job that's downloading and keeping track of the current mortgage rates. In this case, we would use function calling. We would tell our model that it has access to this function known as getMortgageRates, which is within our microservice. We'd first send a request over to the API, and it would express its intent to call this getMortgageRates function. We would then fulfill that intent by calling our API with getMortgageRates. Let's say it returns something like 8% mortgage rates for a 30-year fixed mortgage. And then the rest looks very similar, where you're passing that into the API with the original query, and the model is then responding with a grounded response, saying something like, not great, current 30-year fixed rates are actually at 8% already. And so at a very broad level, you're using this grounded fact source to help, in a generic way, to help ground the model and help reduce model inconsistency. And I just showed two different examples of this, but the grounded fact source can also be other things, like a search index, even like Elasticsearch or some type of more general search index. It can be something like a database. It could even be something like browsing the internet or trying some smart mechanism to grab additional facts. The main idea is to give something for the model to work. And one thing I wanted to call out is that the OpenAI Assistance API that we just announced today actually offers an out-of-the-box retrieval setup for you to use and build on top of with retrieval built right in a first-class experience. I'd recommend checking it out.
OK, so far we talked about building a transparent, human-centric user experience. Then we talked about how do you consistently deliver that user experience through some of the model-level features we released today, and then by grounding the model. Now we're going to talk about how do we deliver that experience consistently without regressions. And this is where evaluating the performance of the model becomes really important. We're going to talk about two strategies here that will help evaluate performance for applications built with our models. The first one is to create evaluation suites for your specific use cases. Working with many orgs, we hear time and time again that evaluating the model and the performance and testing for regressions is hard, often slowing down development velocity. And part of that problem is for developers to not think about a systematic process for evaluating the performance of these models, and also doing evaluations too late. Evaluations are really the key to success here, and measuring the performance of the models on real product scenarios is really essential to prevent regressions and for you to build confidence as you deploy these models at scale. You can think of evals as essentially unit tests for the large language models. People often think of prompting as a philosophy, but it is more of a science. When you pair it with evaluations, you can treat it like a software product or delivery. And evals can really transform ambiguous dialogues into quantifiable experiments. They also make model governance, model upgrades much easier, setting expectations around what's good or bad. And capabilities, evaluations, and performance really go hand in hand, and they should be the place where you begin your AI engineering journey. And so in order to build evals, let's say we start simple and have a human annotators evaluate the outputs of an application as you're testing. A typical approach in this case is where you have an application with different set of prompts or retrieval approaches and so on, and you'd want to start by building a golden test data set of evals by looking at these responses and then manually grading them. As you annotate this over time, you end up with a test suite that you can then run in an online or offline fashion or part of your CI/CD pipelines. And due to the nature of large language models, they can make mistakes, so do humans. And depending on your use case, you might want to consider building evals to test for things like bad output formatting or hallucinations, agents going off the rails, bad tone, and so on. Let's talk about how to build an eval. Earlier this year, we open sourced the evals framework, which has been an inspiration for many developers. And this library contains a registry of really challenging evals for different specific use cases and verticals, and a lot of templates which can come in handy and can be a solid starting point for a lot of you to understand the kind of evaluations and tests you should be building for your specific use cases. After you've built an eval suite, a good practice and hygiene here is to log and track your eval runs. In this case, for example, we have 5 different eval runs, each scored against our golden test data set, along with the annotation feedback and audit of changes. The audit of changes could include things like changes to your prompt, to your retrieval strategy, few-shot examples, or even upgrade to model snapshots. And you don't need complicated tooling to start with tracking something like this. A lot of our customers start with just a spreadsheet. But the point is each run should be stored at a very granular level so you can track it very accordingly. And all the human feedback and user evals are the highest signal and quality. It's often expensive or not always practical, for example, when you cannot use real customer data for evals. And this is where automated evals can help developers monitor progress and test for regressions quickly. So let's talk about model-graded evals, or essentially using AI to grade AI. GPT-4 can be a strong evaluator. In fact, in a lot of natural language generation tasks, we've seen GPT-4 evaluations to be well correlated with human judgment with some additional prompting methods. The benefit of model-graded evals here is that by reducing human involvement in parts of the evaluation process that can be handled by language models, humans can be more focused on addressing some of the complex edge cases that are needed for refining the evaluation methods. Let's look at an example of what this could look like in practice. So in this case, we have an input query and 2 pairs of completions. One that is the ground truth and one that is sampled from the model. The evaluation here is a very simple prompt that asks GPT-4 to compare the factual content of the submitted answer with the expert answer. And this is passed to GPT-4 to grade. And in this case, GPT-4's observation is there's a disparity between the submitted answer and the expert answer. We can take this further by improving our evaluation prompt with some additional prompt engineering techniques like chain of thought and so on. In the previous example, the eval was pretty binary, right? Either the answer matched the ground truth or it did not. But in a lot of cases, you'd want to think about eval metrics which are closely correlated with what your users would expect or the outcomes that you're trying to derive. For example, going back to Sherwin's example of a customer service assistant, we'd want to eval for custom metrics like the relevancy of the response, the credibility of the response, and so on, and have the model essentially score against those different metrics or the criteria that we decide. Here's an example of what that criteria or scorecard would look like. Here we have provided GPT-4 essentially this criteria for relevance, credibility, and correctness, and then use GPT-4 to score the candidate outputs. A good tip here is a show rather than tell, which basically including examples of what a score of 1 or a 5 could look like would really help in this evaluation process so that model would really appreciate the spread of the criteria. In this case, GPT-4 has effectively learned an internal model of language quality, which helps it to differentiate between relevant text and low-quality text. And harnessing this internal scoring mechanism allows us to do auto-evaluation of new candidate outputs. But when GPT-4 is expensive or slow for evals, even after today's price drops, you can fine-tune a 3.5 turbo model, which essentially distills GPT-4's outputs to become really good at evaluating your use cases. So in practice, what this means is you can use GPT-4 to curate high-quality data for evaluations, then fine-tune a 3.5 judge model that gets really good at evaluating those outputs, and then use that fine-tuned model to evaluate the performance of your application. This also helps reduce some of the biases that come with just using GPT-4 for evaluations. And the key here is to adopt evaluation-driven development. Good evaluations are the ones which are well correlated to the outcomes that you're trying to derive or the user metrics that you care about. They have really high end-to-end coverage in the case of RAG, and they're scalable to compute, and this is where automated evaluations really help.
So at this point, you've built a delightful user experience. You're able to deliver it consistently to your users, and you're also able to iterate on the product in confidence using evaluations. If you do all this right, oftentimes you'll find yourselves with a product that's blowing up and really, really popular. If the last year has shown us anything, it's that the consumer appetite and even the internal employee appetite for AI is quite insatiable. So oftentimes, you'll now start thinking about how to manage scale. And oftentimes, managing scale means managing around latency and managing around cost. And so with this, we introduced the final part of our stack, known as orchestration, where you can manage around scale by adding a couple of additional mechanisms and forks into your application. Two strategies that we've seen in managing costs and latency involve using semantic caching to reduce the number of round trips that you're taking to our API, as well as routing to the cheaper models. The first one of these is known as semantic caching. And so what semantic caching looks like in practice from a systems perspective is you're going to be adding a new layer in your logic to sit between us and your application. And so in this case, if a query comes in asking when was GPT-4 released, you would first go to your semantic cache and do a lookup there and see if you have anything in your cache. In this case, we don't. And then you would just pass this request over to our API. Then the API would respond with something like March 14th, 2023. And then you'd save this within your semantic cache, which might be a vector database or some other type of store. But you're really, the main point here is you're saving the March 14th, 2023 response and keying it with that query of when was GPT-4 released. And then you pass this back over to your users. And this is fine, but let's say a month or a week from now, another request comes in where a user asks GPT-4 release date, ? Now, this isn't the exact same query that you had before, but it is very semantically similar and can be answered by the exact same response. And so in this case, you would do a semantic lookup in your cache, realize that you have this already, and you just return back to the user with March 14th, 2023. And with this setup, you've actually saved latency because you're no longer doing a round trip to our API, and you've saved cost because you're no longer hitting and paying for additional tokens. And while this works great, oftentimes it might be a little bit difficult to manage, and there are often even more capable ways of managing cost and latency. And this is where we start thinking about routing to cheaper models and where orchestration really comes into play. And so when I talk about routing to cheaper models, oftentimes the first thing to think about is to go from GPT-4 into 3.5 Turbo, which sounds great because GPT 3.5 Turbo is so cheap, so fast. However, it's obviously not nearly as smart as GPT-4. And so if you were to just kind of drag and drop 3.5 Turbo into your application, you'll very quickly realize that you're not delivering as great of a customer experience. However, the GPT 3.5 Turbo fine-tuning API that we released only 2 months ago has already become a huge hit with our customers, and it's been a really great way for customers to reduce costs by fine-tuning a custom version of GPT 3.5 Turbo for their own particular use case and get all the benefits of the lower latency and the lower cost. There's obviously a full talk about fine-tuning earlier, but just in a nutshell, the main idea here is to take your own curated data set. This might be something like hundreds or even thousands of examples at times, describing the model on how to act in your particular use case. You'd pass in that curated data set into our fine-tuning API, maybe tweak a parameter or two here, and then the main output here is a custom fine-tuned version of 3.5 Turbo specific to you and your organization based off of your data set. While this is great, oftentimes there's a huge activation energy associated with doing this, and it's because it can be quite expensive to generate this curated data set. Like I mentioned, you might need hundreds, thousands, sometimes even tens of thousands of examples for your use case, and oftentimes you'll be manually creating these yourself or hiring some contractors to do this manually as well. However, one really cool method that we've seen a lot of customers adopt is you can actually use GPT-4 to create the training data set to fine-tune 3.5 Turbo. It's starting to look very similar to what Shyamal just mentioned around evals as well, but GPT-4 is at an intelligence level where you can actually just give it a bunch of prompts, it'll output a bunch of outputs for you here, and that output can just be your training set. You don't need any human manual intervention here. And what you're effectively doing here is you're distilling the outputs from GPT-4 and feeding that into 3.5 Turbo so it can learn. And oftentimes what this does is in your specific narrow domain, it helps this fine-tuned version of 3.5 Turbo be almost as good as GPT-4. So if you do take the effort in doing all of this, the dividends that you get down the line are actually quite significant, not only from a latency perspective, because GPT 3.5 Turbo is obviously a lot faster, but also from a cost perspective. And so just to illustrate this a little bit more concretely, if you look at the table, even today, even after today's GPT-4 price drops, a fine-tuned version of 3.5 Turbo is still 70 to 80% cheaper. While it's not as cheap as the vanilla 3.5 Turbo, you can see it's still quite a bit off from GPT-4. And if you switch over to fine-tune 3.5 Turbo, you'll be saving on a lot of cost.
All right, so we talked about a framework that can help you navigate the unique considerations and challenges that come with scaling applications built with our models, going from prototype to production. Let's recap. So we talked about how to build a useful, delightful, and human-centric user experience by controlling for uncertainty and adding guardrails. Then we talked about how do we deliver that experience consistently through grounding the model and through some of the model-level features. And then we talked about consistently deliver that experience without regressions by implementing evaluations. And then finally, we talked about considerations that come with scale, which is managing latency and costs. As we've seen, building with our models increase the surface area for what's possible. But it has also increased the footprint of challenges. And all of these strategies we talked about, including the orchestration part of the stack, have been converging into this new discipline called LLM Ops, or large language model operations. Just as DevOps emerged in the early 2000s to streamline the software development process, LLM Ops has recently emerged in response to the unique challenges that are posed by building applications with LLMs. And they've become a core component of many enterprise architecture and stacks. You can think of LLM Ops as basically the practice, tooling, and infrastructure that is required for the operational management of LLMs end-to-end. It's a vast and evolving field, and we're still scratching the surface. And while we won't go into details, here's a preview of what this could look like. LLM Ops capabilities help address challenges like monitoring, optimizing performance, helping with security, compliance, managing your data and embeddings, increasing development velocity, and really accelerating the process of reliable testing and evaluation at scale. Here, observability and tracing become especially important to identify and debug failures with your prompt chains and assistants and handle issues in production faster, making just collaboration between different teams easier. And gateways, for example, are important to simplify integrations, can help with centralized management of security, API keys, and so on. LLM Ops really enables scaling to thousands of applications and millions of users. And with the right foundations here, organizations can really accelerate their adoption. Rather than one-off tools, the focus should be really developing these long-term platforms and expertise. Just like this young explorer standing at the threshold, we have a set of wide field of opportunities in front of us to build the infrastructure and primitives that stretch beyond the framework we talked about today. We're really excited to help you build the next generation assistants and ecosystem for generations to come. There's so much to build and discover, and we can only do it together. Thank you.